Okay, as promised, we'll see what happens here. And you'll see what I'm talking about.
Jay.
Ha! That's what I was talking about. That crazy Joe Davola. I don't think we can say that anymore, though, in school. So, I didn't mean it. Okay, so we are up to the lesson 8 from unit 4 with our introduction to log functions. So, exponents, we already dealt with exponents. And here's a graph of an exponential function. F of x equals 2x. It's graphed right there. Is this function 1 to 1? You do the horizontal line test, right? Horizontal line test. And yes, this function is 1 to 1. So based on your answer, what must be true about the inverse? Well, the inverse must also be a function, because the original function is 1 to 1, therefore the inverse is 1 to 1. So now create a table of values for the inverse. F of x equals 2x, so you have the inverse. So what do you do with the inverse? You switch the x and y's. So the first one was negative 3 1/8. It would be 1/8 negative 3. And then it would be 1/4 negative 2. 1/2 negative 1. 1 0. 2 1. 4 2. And 8 3. Okay. And then you would go over here and plot them. So x is, I'll just plot a couple of them. 1 0. 2 1. Okay, so on and so forth. And what do we have? And then it was getting closer to 0. So we have 1/2 was at negative 1. Okay, so you have that, something like that. But it does not touch the y-axis. And what do we have? 4. So 1 2 3 4 2. Okay, so it goes like something like that. All right, rough sketch. Yours could be more accurate. Make sure yours is more accurate than mine. Okay, and you can see, remember, an inverse is a reflection over the line y equals x. Okay. So what would be the first step to find the equation for this inverse algebraically? What do you do first? You would switch the x and y. So if we have y equals 2x is the original, so my original is y equals 2 to the x power, we would switch the x and y. That is the first step. Now, this is when we get introduced to logs. If we have an unknown is an exponent, and we're trying to solve for it, we will use logs. So the function y equals log b of x is the name we give to the inverse of y equals b to the x. So you put a log in, all you do is you take this original, put a log in front of the b, lower the b as a subscript, we call it, and then we have the x value. For example, y equals log 2 of x is the inverse of y equals 2 to the power of x. So you can go from the log to the exponent to the log for the inverse. But we also have equivalence. I call this a change of base formula right here. Okay, so it's easy if we start with the exponent and then change to the log. So the log, okay, of the b, the base, and I have the y over here and x. This is the way I like to write it. So b to the y equals x, just like it has right here. B to the y equals x. This is the key concept when you're talking about logs. So if I have, and I'll just do another one for you, log a b to the x, that would be equal to a to the x equals b. And so that's what they are equal. They can go from the exponent to the log, or the log to the exponent. Now, when you're trying to solve for these values, yes, we have calculator buttons. And I'll show you where the calculator buttons are in just a minute. If it's numbers, and of course if the quiz, a test, the regions, and you can put in your calculator, go ahead, put in your calculator. If you want to show work or if they have a variable, what we would do is, since we're trying to solve for this or evaluating, you had set it equal to x. So you change a base, 2 to the x equals 8. And then remember what we did? We did the method of common bases. So it would be 2 to the x equals 2 cubed, x equals 3. Okay, so like I said, if you go to your calculator and your log button, okay, control 10 to the x, there's your log button. So log 2 of 8, boom, gives you 3. Okay? So that's it. So the key thing I would like you to do is I'd like you to be able to change these all. So 4 to the x equals 16. Okay, and then x, of course, is going to be 2. This one equals x. 5 to the x equals 625. And so some of them get progressively more difficult. So we have 5 to the x, and 625 is going to be 5 to some power. So you got to figure it out, 5 squared, 5 to the third, 5 to the fourth, whatever. So we have 5 to the fourth equals 5x. Therefore, x equals 4. Okay. Same thing here. What do we have? 10, you set it equal to x. 10 to the x equals 10 to the fifth power. X equals 5. Equals x. So we have 6 to the x equals 1 over 36. We're still having some difficulty with the fractions. So remember, this fraction means it's a negative exponent. 6 to the x equals 6 to the negative 2. X equals negative 2. And again, we can plug it right in your calculator. Equals x, 2 to the x equals 1 over 16. 2 to the x equals 2, because it's a base 2. 2, 4, 8, 16 to the negative 4. X equals negative 4. This one equals x. 5 to the x, that's a 5. I better fix it so I don't get in trouble. Okay, that's a 5 to the x equals square root of 5. Remember the square root of 5. What does that equal? The square root of 5 is the same as 5 to the 1/2. X equals 1/2. Log base 3 of the fifth root of 9. So we have 3 to the x equals, let me do this all at once, 9 to the 1/5. Okay, applying what we just did in the previous one. So we have to have the same base. So we have 3 to the x equals 3 squared, which is 9 to the 1/5 power. So then x equals 2/5. Because power to a power, you multiply. X equals 2/5. Okay? We have to understand these concepts with the log. This is the basic log introduction. So if we get this part, then we should be able to do all right with the next portion. If the function y equals log base 2x plus 8 plus 9 was graphed on the coordinate plane, which of the following would represent its y-intercept? Of course, you could just graph this on your paper, or on the calculator, sorry. So if we want the y-intercept, remember the y-intercept, x is 0. So you have log 2 of 0 plus 8 plus 9. Don't forget the y equals. Okay? So this right here, this is gone. So you have log base 2 of 8. And as we did above, 2 to the x equals 8, so it's 3. So this will equal 3. If you don't believe it, you can put in your calculator. You can do it out like we did the top 8 examples. So 3 plus 9 is 12, okay, which is choice 1. Now, between what two consecutive integers must log base 3 of 40 lie? Put in your calculator. You have log 3, 40 equals x. 3 to some x equals 40, okay? If you do just put it in your calculator, log base 3 of 40. So we have log 3 of 40. Enter, there's 3.35. Therefore, it is between 3 and 4, choice 3. Okay? How would you formally show that? Because 3 cubed, 3 9 27, 3 to the 4th is 81. Okay, that's how you would show it. Okay? Now, this bottom part here, the calculator use and logarithms, if I just have something written like that, log of x, that's the common log, that's log base 10. So to evaluate it, you would still just go right to your calculator, and you don't have to, if you want to write a 10, you can, but you don't have to. I could just go right here and put in 100. Done. See how it puts it in for you? And it's the same if you put it in. So here's your 10, and then what's the next one? I think it's a fraction. Yep, 1 over 1,000. See, everything just plugs right in. There you go. Enter, bam, -3. Okay, and then the last one. Now we're going to go right here and do your square root of 10 and 0.5. Okay, so those are the last 3 answers. All right, so logs, some of you are going to understand them. Some are going to be confused. Some will love them, some will hate them. But it is a part of, a big part of the exam. Okay, so in a good foundation for your pre-calculus and calculus and any other upper level math class you will be taking. So next few days we're going to be working on them, and yup, you'll get a headache some points, but we'll get you through it. Okay, hope you enjoyed Crazy Joe Davola. All right, and I will see you in class. Ah, there he is.